Hello everybody. During the last weeks I worked on improving my program ASXP to non-photorealistic rendering. It should render according to the article Illustrating Smooth Surfaces by Aaron Herzmann and Dennis Sorin, and as an intermediate step it was necessary to display integral flow lines on the surface along the cross-direction fields of the maximum and minimum sectional curvature, the eigenvalues of the Weingarten matrix. Now, as I said already, a picture says more than 1,000 words, so I will now start displaying the standard form of the surface in the form of a silhouette accompanied with direction field information. You see here these little crosses, a blue line and a green line, indicating two directions on a grid sample of points on the surface. The surface itself is indicated by its silhouette in black, and the sectional curvature curves, sectional curvature direction cross fields give a slight indication about how the surface is really bent and deformed in three-dimensional space. But for now we are not so much interested here in the form of the surface in space, but we want to place now integral lines, flow lines for this direction field here. We want to place them very evenly spaced, with a spacing of 3 pixels in the average between two lines, and these evenly spaced flow lines of the directional curvature cross field, this should later become crosshatch lines for indicating the surface brightness. I will switch off here this flow line field now first. It will vanish in a few seconds. Yes, now it has vanished, and I will show how to color this surface by Floyd-Steinberg dithering. This is also a new effect I added to the program, so it's only black and white dots in different densities, which give a good indication about the lighting of the surface in this position. We are looking straight on this surface along the Z direction. This is I think this is the Y direction, and this is the X direction, and we look through the Z direction. So now we go back to the silhouette display, and we add we go into the flow line mode. We will see in a few seconds. Yes, now we see the cross field of directions, and now I simply do the following. I click here with the mouse, and then an initial flow line is selected, and from this flow line at distance such and such amount of pixels right and left, another flow line is begun, and so on, and so we get hopefully a quite smooth vector field on the surface. Okay, so now you see here a lot of information flowing by. Yes, and now here we have the integral curves. They look really nice. okay, there are some bad points like here or here, which are problematic because of singularities in the direction field. But there are also, in general, it's a quite good evenly spaced set of integral curves, which highlight some peculiarities of the surface, which were not immediately visible, of course not in the silhouette only display, but also not in the crossfield display alone. For example, you see here a kind of circular structure, and you see here this, that this line here plays a special role because the flow lines here and here and here and here, they separate into different directions. Here you can also see a singularity in the field. This is responsible, this is for the lines here going this way and the lines here going this way orthogonal, and here we have the same phenomenon. Here the lines go upward, downward, and here they go left, right. So this was a demonstration of the streamline placement algorithm, which was mentioned in the paper of Herzmann and Sorin. And the algorithm itself was described in creating evenly spaced streamlines of arbitrary density from Bruno Jobard and Wilfried Lefebvre. Very useful article. Okay, thank you very much. I will close now, but I will as a postscriptum, so to say, I will go back to the colors display and will show you how we can tilt and turn the surface. So it's really great. Yes, it's great. Now I can display flow lines even superimposed here on the color display. Now I do this. Now here the calculation goes on and on and on. Where is it? We have 1055 streamlines. So this really looks interesting. Here we have a triple point of the vector field, for example, that we see, and other interesting structure that is discernible on this display.